In this video we're going to look at using separation of variables in order to solve a differential equation. So we'll go through the example first. After we've done the example we'll go look and see the theory. Okay, so if we have the equation y derivative plus 5 x to the 4 y squared equals 0, then what we can do is we can write the y derivative as dy by dx plus 5x to the 4 y squared equals 0. Now what we'll do is we'll get all of the y terms on one side and all the x terms on the other. So we're separating out all of the variables, the y's on one side, x on the other, hence the term separation of variables. So that's equivalent to us saying dy by dx equals minus 5x to the 4 y squared, and we can take the y down and we can take the dx up to the other side, so we'll end up with 1 upon y squared dy equals minus 5 x to the 4 dx. Now what we can do is we can integrate both sides. Okay, so I won't bother writing the line down again, I'll just write it under here. So we can integrate that line there, and we can integrate this one here. So once we've integrated those, we'll end up with 1 minus 1 upon y equals minus x to the 5, and we've got to excuse me, add in our value of a constant c after we've done the integration. Okay, so that means that we can rewrite that, then get rid of the negative sign, and we can take the reciprocal of both ends. So we're going to end up with y equals 1 upon x to the 5 minus c, and we've got our initial conditions y of 0 equals 1. So if when x equals 0, y equals 1, okay, so that's y equals 1. So when x equals 0, we'll have 1 upon, well, 0 to the 5 is just the value of 0, so we've just got a value of 0, and we'll have our minus c. So what we'll have then is c will equal minus 1. Okay, so we put that in there for above, so then we'll end up with y equals 1 upon x to the 5 plus 1. Okay, so again that there is a particular solution. I'll go that out. Okay, so that there's a particular solution there. Okay, and the one we had above here, y equals 1 upon x to the 5 minus c, that was our general solution. Okay, so that's us going and solve this using separation of variables. So what does it mean and how can we write it out in general? So in general what you'll see is we start off with a function of a form that of say g to the y derivative equals f of x. So at that point there, what we've got above is we've got that above whenever we get to this point here. Okay, so we messed about and we got 1 upon y squared dy. Okay, so that's a g of y there, that's a dy, and then we've got some function of x, f of x there, okay, times our dx. Okay, so that there is that little section of the equation there. Now what we did was we noted that y derivative is the same as dy by dx, so you end up with g of y times dy by dx equals f of x, and then we took the dx up, so we got our g of y dy equals f of x dx. Again, that's just us sitting this line here, and then we took the integral of both sides, Okay, so then we integrated g of y dy, and we integrated f of x dx, and once we'd done the integration we'd have been left with the value c at the end. Okay, so that there really is a statement of the separation of variables, and it's just what we did up above. Okay, exactly that there. So you could follow this line here, these here, and it would follow out this general method. Okay, so that's all it is for separation of variables. I'll go and look at a different method and a different example in the next video. Okay, bye bye.